as we know. Okay, so just keep this in mind. This is going to be important later on. And finally, we didn't figure out the exact minutes, right? We're going to have to wait for our iPhones to be fixed. So we might as well just find a precise estimation of time for 95% of the times. Okay, so now we're aware of this gap. Now we know that 1.96 is the actual precise estimation for 95% of the times. And plus 2 is a little bit over 95. So let's use exactly 1.96, okay? I'm just recapping this, just so you know that the statement of 50 and 70, we have to use 95.45%. That's clear. But let's finally find the actual values. So we know from SPSS, because we have the data and we ran the analysis, that the mean is 60 and the standard deviation is 5, right? So mean 60, standard deviation 5, we already calculated the amounts for every single bar. Okay, now let's put everything that we know to use. We know that, we have our central range, which accounts for 95% of the cases, and that's the range that we're going to try to find. And we know that this is the distance. This yellow bar represents the distance between the mean, which is the light blue bar, and the range cut. Why do I call this the range cut? Because there's a range, and I'm cutting this range. So it's the range cut. The distance is going to be equal to, and this is the formula, so pay attention. And I'm going to show this visually, so you're going to get it. And you can always repeat this if you don't. It's going to be the z-score of the range cut. Oh, what is this? Oh, what is this? Well, the z-score of the range cut is 1.96, right? Because we won 95% of the cases. So 1.96, okay? And now we start using the z-score or standard deviations away from the mean. So we could say, hey, it's the z-score plus 1.86 or the 1.96 standard deviations above the mean, right? So it's this z-score of range cut, which is represented by number 1.96, times the standard deviation, which is 5, right? The standard deviation is the distance between this bar and this bar, the pink bar that you can see. Okay, 1.96 times 5, 9.8 minutes, right? Because we're measuring this in minutes. The output that you're going to get is always in the unit of the variable that they're measuring. So also, this is 5 minutes. This is 5 minutes. So keep that in mind. Standard deviation is minutes. Okay, cool. Now, 9.8 is the distance between the average, and it's the precise distance, right, between the average and the range cut, the top range cut. But it's also the distance between, this bar and the lower bar. We're going to talk about that in a second. Now, my question is, what is the point of uppercut? Because it's different than the range cut, right? The range cut is the cut for the range percentage that you're choosing. The point of uppercut, and these are words that I'm really trying to make up. Maybe your teacher uses different words. But the point of uppercut, the upper limit, they might say, is we need to find that out in minutes. That's what we're trying to find. So it's going to be equal to the mean plus the distance, right? So 60 plus 9.8, which gives us 69.8 minutes, okay? This is the upper limit, the point of uppercut in minutes, okay? Challenge now is try to find the lower cut. So you can try to find it by yourself. Pause and try to do it. If you just want to keep watching, let's keep watching. So it's going to be mean minus the distance. Mean minus the distance, 9.8. 60 minus 9.8. 50.2, right? So 50.2 is the lower cut. So finally, we can conclude with precision that 95% of the people waited between 50.2 and 69.8 minutes. Finally, we can get a ding in happiness. Okay. So that's it for today. I hope everything made sense. And I'll see you next time.